Oh, I got 23 viewers so far. That's good. I'll give everyone a few minutes. How's everyone's Saturday going? Mine's going well. Got some stuff done this morning. Got some food. Like my last stream, I have another donut. So, that was good. So I'll be eating live on stream as well. As well as doing some Python code review. Alright, so yeah, like the stream title alluded to, we're just going to spend the next however many hours geeking out over Python, and specifically the async IO or Asyncio. I kind of like pronouncing it Asyncio because it's just easier to say. That library, which is effectively how AutoRecon does everything concurrently. So it's a multi-threading library in Python. That's like the third now that they've come out with. So they had multi-processing, then they had threading, and now they have this one. And this one I think solves a lot of the problems the other two had. So I definitely like this one. But we're also, yeah, we'll be just basically looking over some of the code for AutoRecon. Version 2, I should clarify, because version 2 is the one in beta. It's the one that I released as a public beta recently that a lot of people have enjoyed, which is nice. But first, let's just kick off with a review of Asyncio. And I apologize if you've come onto this stream because you think like, oh, it's Tiberius is going to hack stuff. No, we're just doing code review, and it's not even related to hacking. It's related to a hacking tool, I guess. Can everyone see this? Is this readable? Do I need to increase the font size? Please let me know. I realize I just answered two questions. I asked two questions which could be completely opposite of each other. So, yes, you can see the font size, or yes, you need to resize it. I take it, yeah, it looks good. So, okay, everyone can read it. That's nice. Okay, so I will try and explain Asyncio as best I can. So, if you've done any Python code, you know that the DEF stands for, I think, define, and it's used to define functions. Functions are things you can run. They're like code blocks that you can just run again and again. So if you define it once, then you can run the code somewhere else in your program. They take arguments sometimes. And so the code can operate on these arguments. So in this case we have a function that has a name argument and a delay argument. But it's not actually a function. So you may have noticed this async before the def. And so what async does, it's part of Asyncio. It flags this function and turns it into a coroutine. And I've called it coroutine. You can call it anything. I just figured it's easier to display this so everyone knows this is a coroutine. So I guess what's a coroutine? So what coroutines are effectively asynchronous or concurrent functions that you can run in an event loop that Asyncio sets up. So let me actually run this and show you guys. So I'll just do a sysexit, which I think I need to import sys for. So if I try just to run coroutine, coroutine with test and 1, try and run this. This is Asyncio demo, right? And also you need Python 3, by the way. Thanks for the follow. Who was that? Finovino. Hey, welcome. Alright, so if I try and run this, so all I've done, right, is I've tried to run this coroutine here, and then I exit. So I ignore all of this stuff. If I try and run it, it won't do anything. Because coroutines can't be run like that. That's not how they work. So if this wasn't a coroutine, if this was a function, it would run, right? So that's the first difference. So how do you run them? Well, it depends. So what we're going to do, I have a bunch of examples in this doc, and we're just going to run the script. I'll have to press enter to run each one, but we'll review the code and see what happens. So let me just run it again. Did I save it? I did not save it. There we go. That would help. Alright, here we go. Okay, so the first thing we're going to do is going to run coroutines one after the other. Although these are concurrent, if you just run them the regular way, which is by using this await keyword, you may have seen it says in this error before, coroutine, what's the name, was never awaited. Well, that's what this await does. So when you await a coroutine, it's actually going to run it. And we have two instances of this coroutine that we're going to run. So we're going to run coroutine with the name set to coroutine 1 and a 5-second delay. That's all this does basically. It prints the name plus starting. It sleeps for a bit, however long you put the delay in, and then it says it's finished. And then it also returns a value, which is a string, the name plus the number of seconds and second delay, right? So if this ran, this would return a value of coroutine 1 colon 5-second delay. All right. So we have two coroutines, and if we just run them like this, they don't run concurrently, and you'll see that the time should be about 8 seconds. Oh, cool. Thank you for the bits. I think it's the first time I've got bits on this stream. Cool. Thank you so much. Alright, so if I press enter, you'll see it says running coroutines one after other. So coroutine 1 is starting, coroutine 1 finished, now coroutine 2 is starting, and coroutine 2 is finished. And it took 8 seconds, like I said it would. Okay? So if you just await a coroutine, it runs pretty much just like a regular function. So you can use them in that way. Why you would, I'm not sure, but anyway, if we scroll down, this is how we run coroutines concurrently. So what you can do to a coroutine is you can create a task from that coroutine, and tasks run concurrently. So the way you create a task is you just say okay, asyncio.create_task, and you pass it a coroutine with the arguments, right? So this might look weird to people who've just used functions, because people expect when you do this, this function would run immediately. But as we've seen, if you use a coroutine like this and you don't await it, it doesn't run. So this is fine. So we can pass a coroutine to a function without it running. And what we do is we create task 1 using coroutine 1 of 5-second delay again, exactly the same. And we create task 2, these are just variables, using coroutine 2 and a delay of 3. And then we await both of them. And so you see this code is pretty similar here, right? This time we just awaited each coroutine. This time we're awaiting the tasks which have been built from these coroutines. And so what you should do, when you await a task, it returns immediately, all right, like that. So this is going to return immediately, even though it's still running in the background. And then it will immediately do this one, okay? But then the weird thing that will happen is, because they're still running, this shouldn't fire, until they actually end. So let's press enter. So running coroutines concurrently, so coroutine 1 started, coroutine 2 started again, coroutine 2 finished, coroutine 1 finished. All right, and this is, you see the weirdness of concurrency. All right, coroutine 1 started, then coroutine 2 started. Oh, sorry, it's not the weirdness of concurrency. Coroutine 2 would always finish first. I don't know what I'm talking about. Coroutine 2 finishes first because it's a 3-second delay, right? That's right. If I'd set them both to a 5-second delay, you might also see this, okay? And that's just because they're concurrent. Technically, there can be some like weirdness with like starting them both at the same time, even though one's going to start before the other, because of the way the CPU handles stuff. One might finish before the other, even if it was started afterwards. In this case, this makes sense. Coroutine 2 was a 3-second coroutine, so obviously it's going to finish before coroutine 1. Okay, moving on. So you may have remembered that these coroutines, hang on, let me scroll up, return stuff, right? So they've been returning this string, name plus the delay plus the second delay string, but we haven't been doing anything with that. We've just been awaiting stuff. So what we can do is we can actually collect those results, and the way we do this, we can collect them all together, right, when everything's stopped running. So we're going to create the task 1 and task 2 again, exactly the same way as before, but this time, instead of awaiting them one after the other like this, what we're going to do is we're going to put them in this asyncio.gather function. Okay, and you can add as many tasks as you want here. Just to go, sorry to be a nag, but what is... So we're basically geeking out over Python and Asyncio right now. So this is just explaining how Asyncio works. This is going to be a code review stream. So this isn't hacking. This is at some point we're going to get to AutoRecon and show how AutoRecon works. But yeah, if you thought this was going to be hacking, apologies. No, this is basically Python and how everything works sort of behind the scenes in AutoRecon. A lot of people requested it on Twitter, so I figured I would do it. So right now what we're doing is just an overview of Asyncio, how to do things differently. So far we've run coroutines one after the other. We've run them concurrently, but we haven't done anything with the results. Both of these coroutines return results. And so what we're going to do, we're going to create the tasks exactly the same as before, and then we're going to pass them to gather. So we've passed them to gather here. We're going to await a gather. Await to gather. We're going to set the return value of the gather to results. And what gather does is it will run these concurrently. So it should take 5 seconds again, because that's the maximum time we have. So it'll take 5 seconds. But what it does, after task 2 has finished, after 3 seconds, gather's going to record the result and stick it in a list. And it's going to do the same thing with task 1 as well when it finishes. And then what you can do, it basically returns a list. So we've got results is going to be set to a list. And then we're just going to join the list using a comma, right? So basically every element in the list is going to be spat out as a string joined with a comma as results. So let's see that in action. If I press enter again. So you see coroutine 1 starting, coroutine 2 started, coroutine 2 finishes again. And then as soon as coroutine 1 finishes, we get the results, right? So this was the return value, coroutine 1, 5-second delay for coroutine 1, and coroutine 2, 3-second delay was the return value for coroutine 2. And you'll notice they're in the order we gave them to gather, okay? So we gave gather task 1 first, which is coroutine 1, and task 2 second. So even though coroutine 2 returns first, gather will stick it in the second place in the array. So that's kind of fun, right? If you don't mind waiting for everything to finish, that's how you can get your results. Okay. But imagine you're coding AutoRecon and you have 3 nmap scans running, and you've got one that finishes in 10 seconds, one that finishes in 2 minutes, and the other one finishes in like 5 minutes, right? You don't want to wait for all of those to finish before you sort of start parsing the results, because that would be silly. So what you want to do is you want to run everything concurrently, but collect results when a task completes. Right? Makes sense? So instead of using gather, we're going to use wait. So there's a difference with wait. We're going to create task 1 and task 2 exactly the same way as we did before, but we're going to add them to this list pending, right? So we've got this list pending which has task 1 and task 2 in it. And then we're going to say, okay, while pending, which basically means while pending has something in it, this will return true. So while pending has stuff in it, we're going to await asyncio.wait. We're going to pass pending, the array containing our coroutine tasks, to the wait function. And then we're going to set this return when to asyncio.first underscore completed. So by default, it will return when everything's completed. So we're going to change this. We're going to say, okay, return when it's first completed. And what it'll do is it'll return 2 things. It'll return a done and a pending. Both of these are lists. So effectively, as soon as one finishes, it's going to return it to the done list. And pending will still have everything that's pending in it. Right? So we're going to iterate over the tasks in done, and then we're going to print the task.result. And task.result, the result function of a task, effectively is just the returned value of that task. So what should happen in this one is coroutine 2, which obviously finishes first because it finishes after 3 seconds, is going to return. The wait function is going to put it in this done list, and then we're going to print it. And then what's going to happen is this loop's going to start again. Well, pending still has something in it. Pending has task 1. And so we've passed it to pending again. You'd think this would run it again, but it doesn't. Because the task is still running, technically, Asyncio understands that. If it's passed a task that's already running to a wait, it's just going to wait until that task finishes. All right? This is the cool thing about Asyncio. It handles everything so beautifully. So let's press enter. All right, so we got coroutine 1 starting, coroutine 2 starting. Coroutine 2 finished and we print the result, you see immediately. Coroutine 1 then finishes and we print the result. Okay, and it took 5 seconds still. So I think the key thing here is to remember that you can pass running tasks to a wait and it will understand, okay, they're running, I'll just wait then. Until the first one completes. Does anyone not understand so far? We have gained viewers, so it's possible there are people thinking, what have I stumbled upon on Twitch? And hi everyone. Okay. Let's go down to this one. So there are times when you may want to do something in between a task returning, right? This is so async is the Asyncio library is very similar to JavaScript promises, I think they're called. If you're familiar with JavaScript, I think a lot of Asyncio was borrowed from JavaScript. So instead of promises, they're actually called futures in Python. But it's the same concept. A promise is basically a promise that at some point it's going to return a value, and a future is effectively the same thing. So, yeah, like I was saying, there are times when you may want to run tasks concurrently, but occasionally check on other stuff, right? And this is where timeouts are great. So pretty much, I forget which functions have timeout. Wait definitely does. So this looks exactly the same as the last one. Okay. And yeah, Kusakan Asyncio is effectively the third, I think it's the third threading library in Python. And it's the best one. Okay. Use this smooth. Okay, please don't do that smooth. If you're a bot, I'm going to ban you in a minute if you do it again. Don't spam in chat. Okay, so this looks pretty much exactly the same as the last one. The difference is I've put this timeout equals 1. Okay. But now, because we're timing out after 1 second, these are still going to return, but they're both going to be empty. Well, sorry, done's going to be empty and pending is going to have both tasks in it, right? Because the tasks run for 5 and 3 seconds. So you're going to pass them to asyncio.wait, and then after 1 second it's going to time out. Well, neither of these are done after 1 second, so you're going to have them both in pending still, and you're going to have an empty done. And so we say if done has something in it, we're going to print the result. Otherwise, so if done's empty, we're just going to print timed out. So what we should see here is we should see it time out twice. It should print timeout twice. Then it should return the value here for coroutine 2. Then I think it's going to time out once again, and then I think it will return coroutine 1. I think it could do twice the second time. Let's see though. So I'll press enter here. So again, we start coroutine 1, start coroutine 2. We've timed out, coroutine 2 finished. We time out again, and then coroutine 1 finishes. Okay. So you may think that why I said you could have timeout twice here. If you think about it, you've got a 5-second function and a 3-second function, right? So after 1 second, neither of them have timed out. After 2 seconds, neither of them timed out. After 3 seconds, well, three's timed out, right? After 4 seconds, none of them have timed out. After 5 seconds, it depends, right? This is the problem with concurrency again. After 5 seconds, it depends whether the timeout check comes first or the task comes first, right? So this is why either way you could get you could get 5 happening, or you could immediately get a timeout. So that's why it's a bit odd, but I think it makes sense. And AutoRecon uses this timeout function extensively, and it does so effectively so that we can check effectively what the so AutoRecon 2 has timeout functions. Effectively, you can tell AutoRecon, okay, well if a target is taking longer than X number of minutes, just cancel it. And so that's how I use this, because otherwise what you'd have is you'd have everything running. Say you had 1 scan left, and that scan is taking like 2 hours. It's going to take 2 hours, but you have a timeout of 60 minutes. Then what you would do is, if you didn't have this timeout value, the await's going to wait that full 2 hours. But because I have a timeout of 1 second, every second in AutoRecon, I effectively do a check, and I say, okay, has the timeout value passed? If it has, then we cancel everything and return. But if everything's fine, if the timeout hasn't occurred, we pass the pending object back. So that's why I use that in AutoRecon too. Okay, so this is a trickier one. So this is very much what AutoRecon does, which is running coroutines concurrently, collecting results when they're complete, and starting new coroutines based on the results. All right, and if you think about it in AutoRecon terms, how AutoRecon starts is you start with 3 nmap scans. So one's called nmap quick, and it does the top TCP, so top 1000. One of them is a full TCP scan, and one of them is a top 100 UDP. Okay. Now, clearly, the quick TCP one is going to return first, right? And if it finds ports and services, you want to start running scans on those services, okay? But you don't want to have 2 waits. It just gets complicated. So what you do is you create a new coroutine. Say that you found port 53 DNS server, right? There's a few things that the DNS scans will run. So first is like an nmap of DNS with a few scripts. So what you do is you create a coroutine for that function, for that run, and then you add it to pending, right? So this one is slightly different though, because the pending, I think, is technically not a list, it's a set. So you can't. It's difficult to add stuff to it, and it takes a list. It doesn't take a set here. So the easiest way of doing this is you create pending underscore tasks as a list, and we give it task 1 and task 2 exactly as before, and we pass it pending tasks. But instead of reusing pending tasks, we have this. We keep pending, right? So we have done and pending. And we return when the first one's completed, and then we iterate over every task that's done. We're going to print its result, and then we're going to say, okay, if the result starts with coroutine 1, we're going to create task 3, which is basically a coroutine with a 5-second delay. We're going to add it to pending tasks, so append it, and then we're going to remove the task that's done from pending tasks. Okay, and then the while loop goes over again, and we resubmit pending tasks. So pending tasks, when coroutine 1 finishes, pending tasks should have only coroutine 3 in it, right? Because coroutine 2 should finish first, then coroutine 1. But when coroutine 1 finishes, we're going to create a new coroutine 3 and add it. So this one should effectively go coroutine 1 and 2 start, coroutine 2 finishes, coroutine 1 finishes, coroutine 3 starts, and then 5 seconds later coroutine 3 finishes. So this should take 10 seconds because you just add the biggest ones, 5 and 5, right? So if I press enter, coroutine 1 starting, coroutine 2 starting, coroutine 2 finishes and we print, coroutine 1 finishes and we print, coroutine 3 is starting, and then coroutine 3 finished, it prints its result, and a 10-second time. Okay, and it's 10 seconds because coroutine 3 only starts after coroutine 1's finished, right? So they're not all concurrent. But I guess we could add another task here, for instance, and do 2. Okay, so I think, is this the end? Yes. All right. So now we're gonna get on to really how most of AutoRecon works, because AutoRecon doesn't just use these coroutines, it uses processes, right? So AutoRecon basically just works by scheduling commands, so like nmap commands and like stuff like gobuster. They're all commands that have to be run in effectively not a terminal, but in like a bash shell or something, right? So what I've done here, I've defined another coroutine, I've called it execute, and we get a command and a name. We basically print the name and say it's starting, and now what we do is we use another function of Asyncio, which is create underscore subprocess underscore shell. All right, and this takes a few arguments. So it takes the command we actually want to execute. This, by the way, is all it does is it's going to create, it's going to run the command in a shell concurrently, right? So we pass it. We say, okay, we don't want any input. That's fine, but we want std out and std and it's easier if you just use this pipe. We basically want to read from these because we want to get results back. And you can specify the executable. In this case, it's just bin bash. Alright, so that is that function call there. And this returns a process object. Okay? And this returns instantly. Alright? Even if the command you're passing is going to take an hour to run, when you use this, it starts running it and it returns the process object immediately. So the process object knows, effectively is pointing to this command that's running somewhere in bin bash, and it's tracking it, right? But generally speaking, we don't. If it returns, we want to wait for it to finish at some point. So all I do is I say, okay, await process.wait, and process.wait does what you think it is. It waits for the process to end. Okay. And then it says it's finished, and then it returns the process object. Right? And the process object will basically contain std out and std basically everything that's been sent to them. Okay. So we're gonna create task 1 and task 2 again, and we're gonna create these execute coroutines. We're gonna use these execute coroutines to sleep for 5 seconds, and then echo the name of the command. Right? Command 1. We give it a name, command 1 there. So pretty much, similar to the before. This way, we're just using bash to sleep. And as you can see, you can put multiple commands in here. Right? This is a sleep 5 semicolon followed by echo command. So this is going to get passed by the bash shell. We add them to pending tasks. We have exactly the same thing. So we submit pending tasks there. This is slightly different. So when a task completes, we get the done list again, or the done set. Iterate over the tasks and done. We're going to say, okay, what's the return code? So task.result this time, because it's returning a process, and a process has a return code. The return code, by the way, if nobody's aware, if you run something, so if you run something that works, so echo hello, oops, right, and then you echo $? You get a 0. $? refers to the return code of the last command. So if we run something that doesn't work, we get another error code. Okay, and if we run something that usually the error code for a command that has like completely failed, like if this is the error code for something if it doesn't exist, I guess. Let's see if we do a command that pings and we do that, maybe. Right, yeah. So a ping, if you give it a service where the name isn't known, it will return a 2. Alright, that's all that is. Okay. Now this is where it gets a bit complicated, because we want to read the output of this command, right? And we've got this echo, which is going to effectively output to std out. So what we need to do is we create an array, or a list in Python, an empty list called lines, and we say while the task's result, which is the process, while that process is std out, is not at the end of file, right? End of file is basically the end of the stream. We're going to read a line from std out, and this line happens to be byte encoded, so it's effectively a byte string. So we're going to decode this to UTF-8 and give it to there, and then we're going to append the line to lines, and we're going to iterate, and effectively this is going to keep iterating, keep extracting lines one by one until we reach the end of file, which effectively just means the std out stream reader is completely empty, right? It hasn't got anything else. And then we're just going to print the lines and remove the task exactly as before. So let's press enter here. So we get return code 2, return code 0, and the output is command 2. And then we get command 1 finished, the return code 0, and the output is command 1, and we got a 5-second time. And that's the end of all of that. Does anyone have any questions? By the way, I'll put this demo code on GitHub or something. So before we move on, I want to make sure everyone is everyone's following along. We've lost 8 people. We had 30, now we have 22. I told you this is going to be advanced. Alright, J-Beers, fire away. Yes, you can. You can use Asyncio to use programs and pass the output. And as an aside, so the Asyncio loop runs on one CPU. Okay? You can use multiprocessing to set up multiple event loops if you want. And when I was developing AutoRecon 2 and using Asyncio more, because the first version of AutoRecon used multiprocessing and it used multiple event loops, I wanted to avoid that. And I was thinking, well, there's no way to avoid it because AutoRecon needs to use multiple CPUs. Until I did a bunch of research in HTOP. So if we use HTOP, what I did in HTOP was I went to setup, I went to columns, and then I added processor to the column. And then if I press F10, I can't press F10. Hang on. Yeah. Function F10? Yes. Alright. And now we have a CPU column, right? Which tells me, so this has 4 CPUs. This is a VM that has 4 CPUs. So the CPU ID here, 0 to 3, shows you which stuff is running, right? Now you'd think that if I ran all this again, to be honest, everything here would run on one processor apart from this last bit. Because what I discovered was when you use create subprocess underscore shell, it does not necessarily use the same CPU that Asyncio is running on. What it does is it effectively passes that off to the operating system. The operating system then decides which CPU to assign. So you kind of, if you're using subprocess shell, you kind of get multiprocessing for free. And I can show you that, because what I can do is I can run, if I run Python 3 AutoRecon against localhost, and we keep htop. So notice how I hardly have anything running here, right? There's hardly anything running on these CPUs right now. If I press this, suddenly we're taking off. All right, and so most of this is going to be mmap stuff. You'll see in a minute. So mmap does a bunch of stuff, but if I actually do a filter, if I F4 filter for mmap, yeah, I mean there it's obvious, right? It's using all 4. So it's doing mmap there, and you can see here, right? You've got CPU 1 and CPU 3 now. All right, these are mmap scans that AutoRecon is set up. It's switching the CPUs. If I went to, I think Ferox. All right, there's a ton of Ferox. Ferox launches threads. Look at all these threads. They're all running on different CPUs. So, yeah, even though by default Asyncio runs on one CPU, you get multiprocessing for free if you are running commands, which is really nice. So yeah, we'll quit that. But the downside is that's only for this thing, right? It's only for this. All of these will run on one CPU. So AutoRecon is single CPU for the scheduling bit. but for everything that actually matters, it's it's multi processing. Who's Tiberius, by the way? Name keeps popping up on the computer screen. Well, that's me. I don't know why the name keeps popping up. Oh, you mean this one? That's just my console, so it's gonna have my name in it. Okay, JBeers. I was looking up tool building in Python the other day. I found the OS module which I used to run programs. Yeah, so the OS module does it does it the same thing. But I guess what you could do is you could create a coroutine that uses OS. I just don't see there's any point. Well, I didn't know you were trolling, just a guy. There's so many people in my streams I don't remember everyone's name. So apologies. The error codes, you mean when I did echo that? Is that what you mean? Yeah. Okay, so yeah, to explain this again, every command you execute on pretty much any operating system has a return code. If it returns a 0, so if I echo hello, right, and look at the return code, it's a 0. 0 means, or it should mean, that the command returned successfully. If you run something, no, hang on. I don't think echo has has a way of failing. If you run a command that doesn't exist, right? ZSH or bash is gonna give it a return code. I guess 127 is the return code for something that's not found. If you have a command, so ping, if you give it a random string, so ping, if you can't find the service, will return a 2. These return codes, they don't mean really anything. They're probably for debugging purposes, but they're useful to determine whether a command has executed nicely or not. So you can use them in bash scripts. Is there a difference between multiprocessing and multi-threading? Yes. So multiprocessing will use multiple processors, and multi-threading, I think by default, only uses one CPU, so one processor. Don't quote me on that, but I believe that's the main difference. But you can combine the two, so you can use multiprocessing and then you can use threads within a process. So if you create a processor, like a process pool, using multiprocessing, you can then run threads on that on all the processes in that pool. If that makes some sense. So you can combine them, and you can do that with Asyncio. Asyncio is completely compatible with multiprocessing. Yeah, Goontown, that's exactly it. So you could write a quick bash script, for instance. Let's do ping blah 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 if equals 0, then echo yay fee, which doesn't do anything, but if we change the 0 to a 2, it echoes yay, right? Angel D is here. Hurrah. I am good. We're geeking out over Python. So yeah, generally speaking, you wouldn't do the equals 2. What you would do is not equals 0, and then you would echo no, right? Because generally speaking, the only value you really care about is a 0, right? You want to know if the program has exited nicely, which is, so that's okay. Okay, let's get into actual AutoRecon stuff. Okay, this is the source code for AutoRecon version 2. Kind of, obviously there's plugins, so there's more source code to it than this, but this is the main brunt of it. As you can tell, it's very long. I will probably clean this up and put it in multiple files at some point, but currently the main AutoRecon file is, oh jeez, hang on, get all the way down to it. 1,714 lines. Most of this was written, was not reused from AutoRecon version 1. Some of it was. So I've been a very busy person. Right, so I have a list of stuff that I want to go through. The first was how I use Asyncio for multi-threading, which I pretty much just did. But if we scroll down, so we have a few classes. AutoRecon is object-oriented. If you don't know what object... Actually, does anyone not know what object orientation is? I should probably ask that first. Alright. I'm going to assume most people do. But to do a quick explanation of it, objects are effectively instances of these classes. And classes can have... they're basically a way of storing data, manipulating data. So we have a pattern class that just has 2 values, 2 attributes. We have a target class that has a few attributes, and it has some functions. One of these functions is execute. So there's 2 types of object that can execute things. Targets can execute because targets are what port scan plugins will get. So when AutoRecon starts up, you give it a list of targets, like an IP address. It'll convert those to target objects, and then it'll pass those to the port scan plugins. And the port scan plugins, if I open one up, let's do this one. So we got quick TCP port scan. There's the target object, and it awaits target.execute, and it passes the mmap scan it wants to do. Right. So, oh, I should have probably opened that up completely. Let me double click, and we'll double click that one. Okay. Scroll down. So you don't really need to know most of this. There's some really hacky stuff in here. Just ignore it. The main thing is this line here. So it passes the command to another execute function, which is in the main AutoRecon object. So there is a main AutoRecon object which we'll go to. I'll just actually find it using class AutoRecon. Find. Right. So this is a big class. This is where the brunt of the code is, I think. So if I scroll down to execute, right? You see, this looks pretty similar to what we did over here, right? Yeah, with this stuff. So effectively, we're taking a command, and I mean, this is identical code, right? We have a process. The difference is we pass the std out and the std to this command stream reader. And the reason we do this is actually, I didn't have to do this. I just wanted to make it really easy to write plugins. Because the problem with processes, I could, for instance, when you execute a command, just return the process exactly how the Asyncio create subprocess shell does, right? I could just say to plugin authors, all right, here's your process, do stuff with it, you know, whatever, screw you. But if I did that, if they wanted to read data out of it, they'd have to use this nasty code, which is just, I mean, look at it, it's awful. And this is the best way of doing it, by the way. This isn't like I tried to write complicated code. The std out is a stream reader. It reads bytes. You need to check whether it's at the end of the file. You need, when you read a line from it, you're not reading a string. You're reading a line, like an array of bytes, which I figured most people would be like, ugh, that's not good. So, and then you have to decode it to UTF-8. I mean, most of the programs, I'd probably say all of the programs that AutoRecon runs are just going to be spitting out English, right? They're going to be spitting out UTF-8, like, mostly regular characters. So, I figured, why deal with bytes? Why make people deal with bytes? But the problem is that process returns immediately, right? This returns immediately, and so the issue I had was how do I get it so that I can pass std out and std back to the user along with the process in such a way that you can read from std out and std really easily, even if the process is still running. And the solution I came up with was this CommandStreamReader. So what I do is, if I find CommandStreamReader, class CommandStreamReader, okay. So when we create a CommandStreamReader object, we pass it the stream, which in this case is like std out, and we set it internally, that's fine. And then we have this asynchronous function _read. So this is a coroutine, and it effectively does exactly the same thing that this code does. So what's going to happen is it's going to effectively read lines from output. It's going to decode them. It's going to rstrip them because you don't need extra stuff at the end of a line. That's fine. It's going to do some pattern checking because you need to pattern check. AutoRecon has an automatic pattern checking thing, so if it finds a pattern in the line, it'll record it. So that needs to happen. And that was another reason I couldn't just pass the std out back to users, was because I can't guarantee that a plugin author is going to use my pattern checking stuff, you know. So because I don't trust the authors either. I want to help them, but I don't trust them. And also, it makes no sense if you had to write a plugin and I'm saying, okay, you need to actually run this pattern checking function on your output, otherwise, you know, everything will be bad. So it does pattern checking. It writes stuff to a file if it needs to, which is another thing you don't have to do if you're an author of a plugin. Is, you know, in let's get a good example. Yeah, here we go. Here's a good example, right? If you execute SSL scan against something, you can just pass it an out file, and it'll write to this automatically, right? You don't have to do any of that. Okay, so how it works is it appends each line that it extracts to this internal list. Okay, and then when the stream is over, it will set the ending variable to true. Okay, and then there's these two functions which you can. This is all done concurrently, by the way, so I'll show you that in a minute. But there's another function, readLine, which effectively just pops one line off the list, unless the list, unless the stream is ended, at which point it'll return. Oh, sorry, no. It'll pop a line off the list if there is one. If there isn't one, it'll do an exception, and then if the list is ended, it's going to return none. Otherwise, it's going to wait 0.1 seconds and try again. So effectively, what's going to happen is if you can read lines of output, you'll always get a line or you'll get none. And if you get none, you know that you've at the end of the stream. And read lines is basically the same. It just reads everything. So it operates pretty much the same way. It only returns when it has everything. Okay. So if I go back to the CommandStreamReader instance where we actually call it here. So we execute the command, and then we pass the process.stdout and the process.stdir to two new CommandStreamReaders, which we set to these, and then we create tasks cout._read and cr._read, and create task, remember, instantly starts running the task. Okay, so as soon as this happens, effectively the CommandStreamReader is reading output, checking for patterns, saving it to files, and putting it into a list. And then, only then, do we return all three of these. We return the process, we return the CommandStreamReader out, and the CommandStreamReader error. And so, what a user gets back are these three things, right? And so you can read from stdout if you want to. So a good example of this is the Redis, I think, the Redis plugin. Right. So with Redis, I wanted to check whether if there was no authentication required, then we could execute a few more things. So in this case, all I did was I executed this Redis CLI info command. I only care about stdout, so everything else is just set to an underscore, which you can do in Python, which is amazing. And that pretty much just says, okay, we know there's a variable there. It should be a return variable there, but we just want to ignore it. So all I care about is stdout, and then I can just read a line. Right? I can read a line, the first line from stdout. And this will block, right? This command will just sit there until there's a line from stdout, or if there was no lines returned and the process ends, then the stream is going to end. It's going to return none. So effectively, I guess I kind of messed up here because I should check if this is not none. But I know that this command should return at least one thing anyway. So this is way easier than effectively reading from a stream, converting everything back from bytes, and also checking when the stream's ended. So yeah. So that's how that works. Any questions? I'm definitely geeking out over this right now. Because honestly, when I wrote that, like when I wrote this CommandStreamReader, I was like, this is a solution to a problem I didn't even need, right? I didn't need to do this. I just thought, you know what would be cool is if plugin authors didn't have to deal with bytes, which makes sense. When do we run it? I mean, I ran it earlier. Like this stuff. Ignore this line. This is debugging. I found a bug earlier that I fixed. I guess. Well, I'll give you an example, right? So if I turn the verbosity up to 2, this is the CommandStreamReader working. So the CommandStreamReader in the background is reading these lines from the mmap scans, and because I've turned the verbosity up, it'll print them as well. Let's turn the verbosity down again. Okay. So yeah, the really nice thing about these as well is because with a regular stream reader, once you've read the stream, that's it. You can't reread the stream, right? So if I even was to get rid of this CommandStreamReader, and I want to read the output anyway, AutoRecon wants to read the output to do pattern matching and to output the lines when the verbosity is up. So if I did that, then when I pass the stream back to the user who's writing the plugin, they have nothing left. So this way, at least you're storing it in this list. You're storing the output, and then once the user reads a line, the output gets popped off the list, and it's gone, right? But that's fine, because at least they have it now. Okay. So I've explained how I use Asyncio for multi-threading, how the plugin system works. Okay. Let's quickly cover how the plugin system works, which is actually where I can... Oh, I'm not even in AutoRecon. Let's get down to main. There we go. Okay. Yeah, I can get rid of this line here. Okay. You may expect, or you may be thinking that writing a plugin system in Python is difficult. And by plugin system, what I mean is a system where you have Python code in files in some directory, which you have to load in dynamically, I guess. So when you start running your script, you don't know how many files are in that directory, right? You don't know what's in them. Everything's unknown, all right? You may think that would be difficult. Actually, no. Surprisingly easy. There's a few lines of code you need. So really, this is it. It's just this. So effectively, all we do is we list the contents of the plugins directory, and we iterate over each file within it. Okay, each thing, I guess, and then we say, okay, this is just to make sure it ends with .py and it doesn't start with an underscore. And I did that so you could just disable entire groups of plugins. Like if you wanted to disable all HTTP plugins, really, you could rename http.py as underscore http.py and it just wouldn't get loaded. Okay. Then you just really this stuff. All this does is it works out the directory name and the file name from the entire path of the plugin file. So not that difficult. It then makes sure the directory name has an absolute path. This is where it gets a little tricky. So it inserts the directory name into the internal library path of Python, and it inserts it at position 1 instead of position 0. So position 0 is pretty much the current the directory that the script is in, right? And this is how, by the way, the sys.path is how Python loads libraries or understands how to get libraries. So if I was to print out sys.path, for instance, and then we'll exit. Just knocked my mic. Okay. Everyone still hear me? Good. All right. Let's run it again. So you can see the first is the directory where AutoRecon is. The second is what we just put in, the plugins directory. There's user lib python 39.zip. userlib python 3.9, userlib python 3.9.lib dynload, sorry, a home directory thing in Python. This is basically where all libraries could be. It's a bit like on Bash the path, right? This is effectively what this is doing. This is just how it locates libraries. And we want to put our plugins directory here temporarily. All right, so that it looks there second after looking here. All right, we don't need to worry about looking in here. Okay, all we need to basically do is make sure we're loading these libraries before anything else. And then we just do this try. This is just in case there's a failure. So what we do is we use import lib, which I believe is it's default in Python, so it's an internal library. We import a module, and the module is just the file name minus the extension. And we've already checked, by the way. This looks like it could be silly because I could remove the extension another way, but we've already checked that it ends in .py, so there shouldn't be a reason why this wouldn't work. And so we import the module. So in this case, for instance, for default port scan, it's going to import module default port scan. What this import module function does is it looks through all of these for a file called default port scan.py, and obviously it's not going to be in here. It's not going to be, well, it is going to be in there, so it's going to find it immediately. And then what we do is we say, okay, well, we don't care about the path anymore. We're going to pop it off. So we pop this directory name off the path. I'll probably fix this. To be honest, this was put in this morning to fix a bug. And that's it. Then everything's loaded, right? All this code is loaded. So that's pretty much it. Obviously there's a little bit more to it because I go over and I effectively load some of the plugins. I have to run some stuff, but once this plugin's loaded, I can effectively make sure that the module is AutoRecon. Not module, sorry. I can make sure it's not got the name AutoRecon, because that would be bad. And I can make sure that the plugin, the classes, aren't using protected names. There's some protected names. You can't, for instance, call this class AutoRecon, because there's already an AutoRecon class. If I was to run this code, oh, hang on. I need to take out the exit statement. I just save it. That would be helpful. If I run this code, plugin AutoRecon and default port scan.py is using a protected class name. So there's some protected class names, which are pretty much all the classes that AutoRecon uses internally. So like another one, for instance, would be if I tried to name it CommandStreamReader, right? There's already a CommandStreamReader class, and it will say no, you can't do that. So let me. There we go. So yeah, we do some checks to make sure it's not using a protected class name. Then we check so we're checking each class here within this file, right? And we check if it's a subclass of either port scan or service scan, right? Because what we want to do is we want to register classes which are port scans or service scans. And so we do this. We check it, and if it's one of these, then we use the register function. We make an instance of the class, and we put it in register. And register does a bunch of stuff. So register is how where's the good stuff? Register is how the configure stuff works. All right, it's pretty much all it does. there's a little bit more to it. But other than that, once this is run and once AutoRecon.register has finished, the plugin is loaded. It's ready to go. So I guess we can have a look at the register function. But I mean, it's pretty easy, right? Because you don't even need to do this. This is just for internal stuff, because once you've made an instance of the plugin, you can reference it anywhere, and that's what I'm doing here. So this plugin is an instance of the plugin, an instance of the class. So I can check if it's disabled, and if it's disabled, I'll just return and say, okay, we're not using it. If it matches the name of another plugin, like for instance, if I was to rename all TCP ports as top TCP ports, then you get an error, duplicate plugin name. All right, it's like some basic checks. You know, a lot of this stuff is in here, so yeah. There's even some basic checks to make sure a plugin, because with inspect, this inspect thing in Python, you can extract the functions of anything, really. So what I've done is I've extracted, well, these are methods effectively, so methods of a class. So I can extract the methods of an instance of a class. So for instance, I want to know if the configure method's in there. I also want to make sure that there's a run method at least, or a manual method, right? Because if you create a plugin without a run method or a manual method, there's no point in the plugin. It doesn't do anything. I also check if the run is a coroutine, because run has to be a coroutine because it's running asynchronously. So really, all this is just checks. This isn't really anything to do with loading the plugins. Any questions at all? Chat still there? Cool. Okay. Yeah. So the plugins in the plugins directory are imported there, and then there's an instance made of them. I guess we could look at how the plugins are actually, like, the commands are run. This is filtering and checking, yeah. And effectively, what I do is I have a list that I maintain. Well, there's actually two lists. There's one for ports and one for services. Because obviously you want to keep the port scan plugins separate from the service scan plugins because they run at different times. So after all this is done, we have basically a list of port scan objects and service scan objects, right? So each one of these is instantiated, so you have an instance, and then they're all stored. Those instances are stored. So there's only one instance of every plugin, and that was something I had to make sure we could do. Is even if you're running 5 targets, it's the same one instance of a plugin that's running against them. But that handled nicely, to be honest. So I guess we could have a look at the port scan and service. Yeah, we can look at scan target. Define scan target. So effectively, this is what happens. This is once AutoRecon's loaded everything, it's sorted out all its config files and global files and everything. It makes a list of target objects and it starts scanning them according to, the priority. So this is a lot of just making directories here. So you see it's making a bunch of directories, making JBeers, that is literally on my list next, so we'll do it. And we'll leave it on my list next is how I hacked argparse so it dynamically updates based on loaded plugins. I'm saving the coolest bit for last because it really is kind of cool. Alright, so we start a heartbeat monitor for each target, and the heartbeat is basically a status update. So it's, if I was to run, if I press S, it's basically that but every minute. Alright. And then we get down here. Yeah, so we go through the port scan plugin here, so plugins here. We make sure that the tags match, alright? And then if there are matching tags for that plugin, and there's nothing excluded, it's not an excluded plugin, we create a task port scan plugin and the target. So the port scan is another asynchronous function. So we do port scan, and this literally just, here's the code, await plugin.run. So plugin here is an instance of, for instance, this quick TCP port scan class, which has the run method here, and so it's going to run this method against a target. Okay, and so at that point it's passed it off to this. Okay, and then in this class, so in this function we have a lot of complicated stuff, but I think in the scan target, right, we return, yeah. Okay, so if I go back to scan target, right, so we're scanning, yeah, we do the port scans. This is where we run them. So this might look familiar from the first bit. So this is effectively enumerating port scans to run. So in this case, it's going to have 3. It's going to have this one, and if I scroll down, this one, right? So it has 3 port scans that it runs by default. It puts them all in pending, right there. It creates tasks based off the port scan, and then it puts them in pending. And then it does this asyncio.wait on pending, return when is the first completed. So when one of them returns, this is going to break out of this. Or there's a timeout. All right, it's a timeout of 1 second. If it times out, we check first if the target timeout is even enabled, or if it's and if it is enabled, sorry, we make sure it hasn't timed out. There's a few bits here for if we're forcing services, but generally speaking, what we're going to do is we're going to extract services from these, and so yeah, it's going to return services, and from the services we down here somewhere. This is all basically just service checks. Yeah, we're gonna add them to pending. So we're gonna create service scans, service scan tasks, and we're gonna add them back to pending. And obviously, then pending is gonna go into this massive not while loop, but massive loop again for here, right? And yeah, that's how it works effectively. So the timeout is key, and the first completed is key, because the things that first exit are the mmap scans, and once the mmap scans exit, you get the services back, and then you can extract services from. All right. how I hacked argparse so it dynamically updates stuff, right? This is, as far as I know, the last thing on my list that people should know about. So JBeers was asking how you create the like client menus and stuff. So instead of showing you how it's done here, let's actually create a new program. And I'll just copy this one line here. Okay, so we're going to import argparse, and we're going to put argument parser description our test program. All right, and then, because I always forget the syntax of this, it's not pass known args. Just 2 seconds. This is all horrible stuff, horrible stuff, horrible stuff. There we go. Okay. So we want to do this. So if we just, I think, print args. Oh, let's save it as our test.py. All right, and then clear it, Python3 test.py, namespace, good. Okay, right, so if I do -h, yeah. So it automatically builds stuff, right? Argparse is great. It's pretty much the best argument parser library in Python. And so all you do is you create an instance of the argument parser, we've got a description in there, our test program, and then you tell it to parse the arguments, right? And in this case, we had one argument, which is, it always puts a -h or a --help by default. And so it's going to use the description, it's going to have a usage that it auto-generates. It has the description, which we put in here. And then, in this case, optional arguments, right? -h, --help. Okay? So there's multiple different types of arguments you can have. Let's go through a few. Let's scroll up. Apologies, this is all... We'll get on to how I hacked everything. So, if you want... if you want to have a... Let me just zoom in a minute. If you want to do something like test.py and have a bunch of arguments like test, test2, test3, right? What you need to do is grab... right, yeah, so... You need to do parser.add argument, and then what you would do is you would, let's just say thing, right? Action equals store. We need to actually store the values, and then nargs equals an asterisk. Sorry, plus, I think, because we need at least one. So if I do -h now, so effectively what that did is it said, okay, you can have one thing, and then you can have optional other things, right? If I change, that's what the plus means. You think about nargs, if you understand regex, a plus means at least one. If I replace this with an asterisk, what you would do is it becomes completely optional. You can run the program without just specifying like thing. You can run it like that, or you can say test1, test2, right? And you can see in this namespace, I'm just printing stuff. So it creates an array called, a list called thing, and it populates it with whatever you have in it. Okay, so that's if you just want simple arguments, no like command line options or anything, no dashes. You just want to store stuff. So let's change that back to a plus and require at least one. And if I save it as a plus and I try and execute it without one, it'll complain. Okay, so it has error catching in it. You can override all of this, by the way. This is all changeable. So let's add some actual options. So we do parser dot add argument. JBeers wanted what dash s for seqr. So you can pass it multiple things. So you can say seqr, right? Action equals store again. Let's say we want a value for it. I'll save. You put like seqr stuff. I didn't know. All right. That should be fine. So it's optional still. If you put required equals true, you'd have to have it. But if we do that and then do -h, now we have this save option. If you don't like it, well, I guess this was I guess it could be like a file name, right? Save to a file name. If you don't like the save thing being there, what you can do is, what's it called? I'm gonna have to check. Please tell me there's one in here. No. Oh, okay. I'm gonna have to Google it. Where's Firefox? There we go. All right, let's argparse. Metavar, I think. Right, that makes more sense. So you can change metavar to like output file. And then if we do it again, that's clear. And then you have output file here, which looks a bit better, right? But say you didn't want the option, and you say -s should just be like, okay, if -s is enabled, it's going to save it somewhere, right? So instead of this, you do a store_true, and if we do that, oh yeah, store_true should not have a metavar. So if we save it and rerun, so now you just have a --save. So if you do, so you would use it like --save or -save. Sorry, -s, right? And so now we have save equals true. All right. You can also set stuff like, let's just do -t for threads. This is going to be an action equals store, and it's going to be a type of an int. All right. So if we do clear again and do -h, you can see now if we tried to do t threads and then put type there, sorry, test. All right, invalid integer value threads. If we change this to a 1, now we have that. All right, so you can tell it to store threads or something. Hang on. Another cool thing is, I'm just trying to find the name. Okay, count, that was it. So you might be wondering how you do stuff like -v, dash dash v, like something like that? Like, is it just parser.add argument dash v and then parser.add argument dash vv? Is it that? No, it's not. You can set this up with a action equals count, and then, oops, sorry about that. I'm just going to move my mic up a little bit. So now if we do dash h, you see dash v is just on its own down here. You can add help text to all of these by just using the help option. But now if we do dash v, we get v equals 1, right? If we do dash v v, we get v equals 2. If we do dash v v dash v, we get v equals 3, right? I don't think you can do, yeah, you can't do that. But that's how you do counting, right? So, you know, you could just put as many v's as you want in here and you'll get 9. There you go. That's how you do that. If you want parser.add argument, let's say dash dash type, and you want, I believe it's options, and then you give it an array of A1, A2, A3, action equals store again, and we'll clear this out. Oops, we'll clear that out, and we'll do dash h. No, it's not options. What is it? Hang on. Trying to find the options thing. There's definitely a way of doing it. Yeah, that doesn't work, does it? Hang on a minute. There's one of these. It's not in here, but it's down the bottom, I think. Choice. That's it. Choices. So it's not options. It's choices, which is the same as options, really. Okay, so now you have a type value, and you can use A1, A2, A3. So if you try and do type B1, right? Error, invalid choice B1. You got to choose. So you choose A2. Great. And then you have a type A2. All right. Yeah. So pretty much argparse will pass all of these, and yeah. You can then. So I'll show you how to extract stuff. So once you have this args value, everything you'll notice gets saved using the name, the big name. So if there exists one, right? So here we had threads and save, and here we just had v. So v is it. If we had something like type dash hello, whatever, okay, then if we do type dash hello, it'll save it as type underscore hello. That's the only thing to watch out for, is it will convert dashes to underscores. And then how you reference them, let's say we want to say okay, print args dot type underscore hello, and then it'll print A2. Yeah, and we can check, like, okay, if args dot v is not none, print hello times v. I think that should work. So now if we clear and we just do 1v, v is, oh, hang on, args.v. Right, hello, if we do dash v, hello, hello, right? If, for instance, you don't like them, so you want a name like you want to have type hello here, but you don't want the value here to be type hello, you can do, it's a destination variable, I think. Hang on, I know I've got one in here, I think. Yeah, dest, there we go. So you can do dest equals type, right? And now this will be type. So even if you have to use type hello, it's going to save it as type. The other cool thing you can do is if you set up parser.add argument, let's just say -n, action equals store, nargs equals plus so then what you can do, let's try that. So what we can do is we can do -n 1 2 3, and you get an array 1 2 3. So you might be wondering why I put a double dash here. That's because if you take that out, it will think that test is one of these options that you want -n to have. Okay. So you put, the general rule is you put double dash when all the options are done, and you want to put the actual like end target thing. But you can also do like -n4, right? And then, oh, okay, that overwrites it. Okay, yeah, so that will overwrite it. There is another way of doing a similar thing where you have to do -n. If you do -n multiple times, it'll add them all together. I forget which one that is. I wonder if it's in here. There should be a list of them somewhere. But yeah, there's another way of doing that. So that's how you use argparse, which is, it's just amazing. It's so much easier than anything else. I think there used to be optparse, which I think argparse is based off. It's just way better. So, as you may know, going back to AutoRecon, let's clear this and decrease the size a little bit. If we run AutoRecon Python 3, AutoRecon -h, we get all these regular defined arguments, and then we get plugin arguments, and then we get global plugin arguments. All right, and these are all defined dynamically. Just like the plugin system, argparse doesn't know about any of these. AutoRecon doesn't know any of these until it loads plugins. And this causes two problems. The first one is, how do you even load these in? And the second one is, what happens if someone wants to do a -h, and like you have to do a -h to load this, and then somehow parse the plugins and then show the plugins. So it's complicated because one of the options as well is plugin directory, right? If we were to, let's create plugins 2, right? If we were to do -- plugins dir plugins 2, right? Oh, hang on. Plugins 2, not that. Alright, there are no valid port scan plugins. What we'll do is we'll copy default port scan into plugins 2. Alright, so you'll see now that I'm using a new plugins directory, there are no plugin arguments other than the global ones, right? And if I switch it back to plugins, you get these. So you have to parse the arguments from the command line, extract plugins directory, load the plugins, add arguments to argparse, then rerun the plugin, rerun the argument parser so that you can display them if they exist. And the problem with that is if we were using, let's use this script again, right? If you pass it a thing it doesn't recognize, right, it's going to complain. And obviously, you might have plugin arguments defined on the command line that you know exist, but the argparse doesn't know exist because it hasn't loaded the plugins yet. So you have a kind of like chicken and egg problem. What is useful about argparse is instead of using parser.parse args, you can use parser.parse known arguments. And what that will do is it will parse anything it knows and ignore any options which it doesn't know. It won't error out. So this is what we do first. We parse the known arguments, and then we're going to extract stuff like the config file, because the config file contains, like, you can set up the config file so it points to a new plugins directory. Okay, so we have all that. We load the plugins directory, we load the globals, we load all of our plugins in here. Then I guess we can go over plugin arguments, right? Because it's like global plugin arguments, because if I clear this out, we have our plugins directory set to that. We get these global plugin arguments, but where do they come from? Well, they came from the global.toml file. All right, and you can so easily create these. This is just literally, I created effectively a toml front end to argparse. So if you want to create a global option called, I don't know, let's just do jbeers because he's the only one chatting right now. All right, help equals this maniac hacks on his phone. All right. Okay, and then if we run -h again, you get a global.jbeers value. This maniac hacks on his phone, right? So that, you know, how does that work? Well, by parsing this, we have to preface everything with global. That creates effectively a list in toml. So these are, well, not the list really, it creates a dictionary. These are all keys, which convert to the argument string. We go back into here. You'll see we'll load the global file, the global config file. We'll do a toml.load, which basically parses it and creates this huge dictionary. Hang on just a go. I think you everything. No problem, man. Yeah, you have a good sleep then. Thank you very much for coming along. Okay, and then what we do is we iterate over the list of items. If the key is global, which it will be if you know, in these. Then we iterate over the list of items. All right, and the items will basically be this key to this string, right? And so we say, okay, firstly we give everything a metavar of value, which is where this comes from. Patatcat, maybe this will be uploaded to YouTube. Yeah, but I'll probably do that. And then we say, okay, if there's a default option, then we'll set the default, because one thing I forgot to mention in here, you can set defaults for everything. So for instance, you can set default equals 20 to the threads maybe, and then if you go to, let's clear this out again, hang on, let's go back to one where it was, let's go do -h, here we go. You should see, why did that not work? Oh right, yeah, and if I add the help, I can say default is %s default. Oh, actually no, I think just %default s. I believe that's the syntax. Yes, alright, so it just says default 20, right? So you can set defaults. So if you have a default value, then it'll set this, basically it's keeping track of this in a dictionary, right? So I have a dictionary here where metavar equals value, which again is why all of these have values here of value, right? So if we were to set a default, default equals test, that would set a default, so then we can put default, we can put the same %default string thing there. Now if we clear this, you know what I'll do is I'll pipe it through tail. Alright, so now we have a default value of test there. And then you can do stuff like that, right? So you've got help text, you've got type. So there's a few types you can put in. Most of these are exactly, you know, the same stuff as before. So if you wanted to, for instance, make this a choice, you could do type equals list. Type equals choice, and then you would have to put obviously choices equals, and then put an array. So we'll do test 2, test 3, and then if we rerun that, you see it converts it to that little array there. But basically everything's kept in this options dictionary with the key to the value thing. Why it's kept in a dictionary is because of this really cool thing in Python, where it's this line here. So this we create basically a section in the argument parser, so a group, add argument group called global plugin arguments, and then from the global plugin arguments we add this argument where we're going to say, okay, it's going to be -- global plus the key, which has been slugified. Slugify is effectively just converting it to a nice thing. So if I was to, for instance, change this to jbeers at test, I think what would happen is, I couldn't parse it because you can't put values in there. Let's see what values we can put in there. Can we put an exclamation point? No. All right. But for instance, say there was, you know, I don't know, stuff like, I think maybe 3 of them in a row will do it. Yeah, okay. So Slugify basically makes really awful things into nice looking things. So we've got jbeers -test instead of 3 dashes there, right? Okay. And then you see this option. So this is the options dictionary we've been talking about. But we're using double asterisk before it. And this is because if you remember, add argument takes arguments like this, right? These are called keyword arguments. They're referred to a lot as keyword args, like that, right? If you have a function that takes keyword arguments, where a keyword argument is something equals something like that, and not just like a value on its own, right? Like this one. These aren't keyword arguments. This isn't a keyword argument. This is a keyword argument. Has a keyword in it. That's the clue. If you have any function in Python that takes keyword arguments, you can pass a dictionary of key values which match those keyword arguments using the double asterisk syntax, and it will work. Alright? Let me show you exactly what I mean here. We'll use this again. So let's define a function. We won't call it function. Keywords. Alright? And our function keywords is going to have a standard argument A. It's going to have B equals test, right? It's going to have I don't know, test equals thing, right? And in this argument, all we're going to do is we're going to print A, we're going to print B, and we're going to print test. Right? Let's run that. We probably need to call it as well. That would help. Keywords. Let's do. A will be tib. B will be. Let's do jbeers again. And we'll leave test because test will just default to thing. Right? So if I do Python 3 test.py, oh, I need to actually put something in there even though we're not using it. Okay, it's gonna output tib jbeers thing, right? That makes sense. Okay, so tib jbeers and thing was default, so it goes to default. If we now create options as a dictionary, and we say, okay, we have a dictionary value called B, so a keyword called B, which we're going to set to tib, and we have A's. Right, yeah, we can't do B set to tib. We can do B equals jbeers, because tib is the other argument, right? And now if we do test is set to thing 2, let's say, all right? So we have a dictionary where we have a key B, which is set to jbeers, a key test, which is set to thing 2. And note that that's, they're the same keys, all right? So now if we, instead of B equals jbeers, we put asterisk asterisk options, what this will do, it'll take this dictionary and it'll convert it to this kind of format here. And it will understand that this should be the B argument, this should be the test argument. And so what we should do, if it works, is it should print tib jbeers thing 2, all right? Which it does. So that's a cool little trick you can do in Python. But yeah. So, back to AutoRecon. That's what we do here to get global arguments. So that's global arguments sorted. To get plugin arguments sorted is a lot more hassle. Where is it? But effectively, what it is actually if I go, so when the plugins are registered, let's go to a thing that has plugin arguments. The HTTP one is probably good. For the directory search, directory busting, because directory busting has a lot of arguments. So what happens is I created these functions: add choice option, add list option, add option, right? So effectively add option is just like a regular argparse. Add list option is, if you want to add if you want to add the nargs equals +1, so basically an optional number of things. Choice is exactly the same. If you want to add choice option, so these are all effectively front ends to argparse. So if I go to the add choice option, it's defined within the service scan. So yeah, so it's defined within the plugin object, right? And so you have all these things here. So really all they're doing is taking the values you give them and passing them to the add argument of AutoRecon, which does some more stuff to them. So let's go to AutoRecon's add argument. So define add argument. It's here. So what's happening is we're taking the name of the option, we're making it into a dash, right? With the plugin slug. So the plugin slug is effectively, if you define it here, you can do it there, but it's effectively the name converted to a nicer looking slug. Plus the name of the option that you had. And then effectively we're just passing it the same way. So we're passing the name to the argparse group, and we're doing exactly the same thing here. We're taking keyword args and we're putting them directly into this add argument thing. And so that's how that works on the fly. So effectively the plugins are loaded, or effectively, yeah, argparse passes what it can. It extracts the plugins directory if it's non-default. We use that to load the plugins. Then once the plugins are loading, they'll add some more options to argparse, and then we parse it again. And that's how we get effectively the full list of arguments. So if I take out the plugins directory, right? So that's how we get all these. There's a bit more complicated stuff when it comes to overriding values. So, for example, let's take the Dirbuster tool. You have several options. Default is Feroxbuster, but if I go into config, where's my config file? Come on, there it is. If I go into the config file and I create a new section for Dirbuster and I set the tool equal to GoBuster, then if I rerun this, it changes the default. This I don't have to do this. This was purely because I felt like it looked better. That if you had a config file that changed the default, it should probably update the default. The way I got this to work is a massive hack. So let's take a quick look at that. I'm gonna go down to parser dot. Here we go. All right, and remove those. So if we scroll down, let me exit out of this. Scroll down to config. Not that. This is the global stuff. We don't care about that. Okay. Here we go. This is the horrible section. So we're parsing options here from the config file. So we've got global options, which are not the global stuff you might think about. They're global options you can change from here. So you could, for instance, change the global domain in here to something by unchecking this. That's all fine. What's awful is these 3 lines of code. effectively what it does is if it finds, oh geez, it's horrible, but it looks at the key and the key to value. So in this case, the key value is like dirbuster.tool equals gobuster. It looks to see if argparse has a default value for that. If it doesn't, you're not even supposed to be able to do this really. It's basically messing around with the internals of argparse, but you can use this function to set defaults, and you have to pass it a dictionary again using the asterisk method, where you have this just horrible key value thing. But it's not just key value. I have to slugify everything because obviously the keys might be weird. So yeah, that's how that works. And then again, for config values like hang on, if I do head -20, not 20, sorry, 30 maybe. Right, so max scans default 50. I think if you update, believe if I update max scans to 30 up here, yeah, it changes the default to 30 again there. So that's this code right here, which kind of does the same thing. It's just horribly hacky, and I didn't have to do it. I just wanted to. But yeah, that's how I hacked argparse, so it dynamically updates everything based on the plugins. That was the end of what I was going to talk about. Does anyone have any other questions or things they want me to show before I end the stream? Because it's been just over 2 hours to show a bunch of complicated stuff. It's been quite fun though. Any questions at all? Thank you, JBiz. I hope. I mean, yeah, the code's all there for people to see as well on GitHub. So, what I'll do is I'll commit the demo code as well somewhere. Yeah. I don't know when my next stream will be. Probably next week, maybe. I'll try and do some fun stuff. We'll probably do a few boxes with new and improved AutoRecon version 2. Do some live. You should do it, man. You should definitely stream. Streaming's fun. Yeah. I didn't think it would be this much fun, but it definitely is. It's nice to talk to people as well on the stream. You know. But yeah. Definitely do some stuff. It's because especially I would just say, you know, don't be scared of looking like an idiot, because I look like an idiot all the time on my streams, and it's just fine. Like chats with you generally. Like if I spend 3 hours on a stupid box, it's fine. You know, it just shows that we're all human. None of us are like super hackers who can do everything without, you know, stumbling. Everyone stumbles. I think that's why more people don't stream, is they just feel like if they make mistakes, people are going to think they're idiots. But I don't think that's true. I think most people give you the benefit of the doubt. Nice one. Yeah, let me know, and I'll try and catch it. I'll follow you on Twitch after this stream. Exactly. Yes. As long as you learn from your failures, that's good. So definitely stream stuff that's hard. You know, it doesn't matter if you don't do it. Part of it's the process. Plus, to be honest with you, you have people in chat who usually help out. They give you good ideas, so it's nice. Appreciate that, Patak Cat, but I definitely sometimes look like an idiot, and it's fine. All right, guys. Thank you so much for joining. This was a lot of fun. I'm glad we got to dive into some of the intricacies of Python and Asyncio or Asyncio, however you pronounce it. All right, everyone, have a great weekend. I'm gonna quickly put the stream ending thing up, just so you get my social information. If you are not following me on Twitter, I am at 0xTiberius. I have a Discord server where we all hang out and have some fun in there. It's a great community. Obviously, I've got a YouTube channel where this will be at some point. And of course, if you're not following me on Twitch already, please give me a follow. It really helps spread the word. Other than that, thank you so much, everyone, again. Have a great weekend, and I will see you next time.